Okay, so here are the sum and difference formulas that we're going to be using. So what they say is if I have sine or cosine or tangent of the sum or difference of two angles, these are the formulas we can use to kind of expand it out and evaluate. Okay, so like if I had sine of an angle plus another angle, it's going to be sine of the first angle times cos of the second angle plus cos of the first angle times sine of the second angle. Okay, and then the same goes if I have a difference. Only change is the sign here in the middle. For cosine, the formula looks a little different. So it's cos of the first times cos of the second angle minus sine of the first times sine of the second angle. So just kind of be aware that the sign here is kind of switching a little bit on us. So I had the sum of two angles, but when I expanded in the formula, this is a subtraction. Just be careful and kind of follow the formulas when you're going through. And then for cosine, if I have the difference of two angles, it's still cos A cos B, but now it's plus sine A sine B. Okay, and then we have our tangent formulas here. They're involving a little fraction here. So tangent of A plus tangent of B over 1 minus tan A tan B, and then likewise for the difference of A and B. So we just have to be careful to not try to distribute sine, because sine is not a number to be distributed. It's actually an operation. So I can't distribute an operation. So sine of A plus B is not the same as sine A plus sine B, right? We have to use the entire formula to evaluate. And you have a couple of homework problems that just kind of show you that they are definitely not the same value. Okay. So let's look at the example we were talking about before, sine of 105. And again, we said 105 is not on the unit circle, but 105 is equivalent to 45 plus 60. All right, so I didn't really change any value here. I just split up the 105 into 45 plus 60, which is equivalent to 105. So these are still equivalent. And now I'm going to use the sum formula here for sine. So I'm going to follow exactly what it says here. Okay, so it says my A is 45, my B is 60. So I'm going to go sine of 45 cos of 60 plus cos of 45 sine of 60. Okay, so following the formula, that's all I needed the formula for. Now I'm going to the unit circle and saying, well, what is sine of 45, cos of 60, and so on. Sine of 45 is root 2 over 2 if we're looking at that unit circle. Cosine of 60 is 1/2, right? Plus cosine of 45 is root 2 over 2, and sine at 60 is root 3 over 2. And then we just evaluate, right? I have order of operation. I have multiplication. I have to do that first before I can add. So I can multiply these two fractions together and I get square root of 2 over 4. Right? Root 2 times 1 over 2 times 2. And then here, same thing. Root 2 times root 3 is root 6 over 4. So I can leave it like that. I can factor out a 1/4 if I wanted to, but this is good enough. And I cannot add root 2 and root 6 because they're not the exact same square root. Right, so this would be good enough. And this is the exact value of sine of 105. Right, now we can see why it's not on the unit circle. Not so easy to write down. All right, let's try another example. But now it's cosine of negative 105. So we knew what added and subtracted to positive 105. Now for negative 105, I'm just going to use some of those same numbers, but I want a negative. So let's say we say it's cosine of, I'll use 120 minus 225. So before we said 225 minus 120 is 105, but now that I want a negative, I'm just going to make sure my smaller number becomes the first, and then minus 225. So this is equivalent to negative 105, so we're good here. And then because I have the cosine and I have a difference, I'm going to come up here and use the cosine difference formula. So it's cos A cos B plus sine A sine B. So I'll put here cos of 120 cos of 225 plus sine of 120 sine of 225. All right, so if I look at my unit circle, 120 is, I'm just going to draw it on the side here. If I look at my unit circle, 120 is here in the second quadrant. Cosine is 1/2, negative 1/2, comma, √3/2. So cosine at that point is negative 1/2. Sine is √3/2. And then 225, which is here. So I guess I'll put a 120 here. And then 225, which is here, kind of in the middle of quadrant 3. And that would be negative √2/2, comma, negative √2/2. So both sine and cosine are negative down here. So cosine of 120 is negative 1/2. Cosine of 225 is negative √2/2. And then plus sine of 120 is √3/2 times sine of 225, which is negative √2/2. Okay, so then again, order of operation, I'm going to do my multiplication first. So I get negative 1 times negative √2 is positive √2 over 2 times 2. And then positive √3 times negative √2 is negative 6. So instead of plus negative, I'm just going to put minus √6 over 2 times 2, which is 4. And that's my exact value of the cosine of negative 105. All right, so if we look at our answers, they look very similar. We're just going to have usually a combination of these guys just kind of moved around, maybe flip-flop, maybe the sign will be different. But we'll start to see a lot of commonalities within our answers. All right, so sometimes we're actually given an expanded form and we're asked to just rewrite the expression as the tan or the cosine or the sine of one angle. So right now I have tan of 140, tan of 60. I've got two different angles that I have to evaluate, but sometimes we're just asked to kind of condense that down to tangent of one angle. So if I look back here at my tangent formulas, what I'm given is the right side. I'm asked to put it back into this form and not even leave it as like a number minus another number. I want to actually get it all the way down to just one number in here. Okay, so we're just going to condense it down. So let's look at what we have here. Let's see. I don't think I can fit it all. We'll look at it. So we have tan of 140 minus tan of 60. So let me just look at the formulas real quick. When I have a numerator that says tan minus tan, I'm using the difference formula. All right, so I have this formula here, and then let's check that the bottom is right. It says 1 plus tan of those two angles. So same thing here, 1 plus tan of A, tan of B. So in my case, my A is 140 and my B is 60. So I'm just going to plug it right back into this formula here. So the formula says that all of this is supposed to equal, tan of A minus B. All right, so tan of 140 minus 60. And now I'm almost down. It said condense it down to tan of one angle. This is tan of a couple angles. So tan of 140 minus 60 is 80. So this is me condensing it all the way down to just the tangent of one angle. Okay, once you know your A and your B, you go back into the formula and kind of go in reverse. One more example. So same idea, rewrite the expression as cosine, sine, or tangent of just one angle, right, of an angle. And here now I have cos, cos minus sine, sine. Automatically, when I see cos, cos together, I know that's a cosine, a sum or a difference of cosine. So let's look at the formulas. Mine is cos, cos, sine, sine. So I'm looking at these two, but because it says minus, remember how sine kind of goes in, cosine kind of has the opposite of what we think. There's an addition sign here. If it's a sum of angles, my expanded form has a subtraction, right? So that's where I'm at. I have cos, cos minus sine, sine here. So that means when I condense it back down to 1, I'm going to have cos of my first angle plus my second angle. Right, so let's rewrite this. So instead of expanding it all out, I'm going to bring it back together as cos of the first angle plus the second angle. Okay, our inclination is just to try to distribute whenever we see parentheses, but we have to remember cosine is not a number to be distributed through. It's an actual operation. So we're trying to find the cosine of these two angles added together, right? Order of operations says parentheses first, then evaluate. So we're not able to just distribute a cosine through. So it actually expands to all this or condenses back to this. And again, I don't have cosine of one angle here. There's two, so I need to combine these together. So it's really going to be cosine of pi over 7 plus pi over 5 need to have a common denominator. I'm going to get that common denominator, which is 35. So I'm going to multiply by 5 over 5, here by 7 over 7, and I end up with 5 pi over 35 plus 7 pi over 35, which again is still not cosine of an angle. These are still two separate angles, so let's bring them together. Now that they have common denominators, I can put it as 12 pi over 35. And now I've condensed it down to cosine of one angle. All right, and in the next video, we'll go through some kind of application problems with identities.